Alright, the purpose of this video is to give you some helpful hints on your assignment for your Chapter 8 review, which starts on page 379. Problem 20 is just a start times growth to the x problem. If the black bear population is increasing by 2%, remember in growth we need to add the 1, so it becomes 1.02 for the growth rate. And how many years? So 8 years. So we're putting in, where the x is, we're putting in an 8. And then if you do that on your calculator, you'd get 11,717 bears. All right, problem 21 is a half-life problem. So looking up that formula from your note card, you're starting with 300 milligrams of the isotope. It has a half-life of 3.8 days, so we put that in where the h is in the exponent, and the time then is what I'm looking at for 21. They are asking for 8 days. So if you put the 8 into the formula and use your calculator, you should get 69.7 milligrams. All right, problem 50 is another start times growth to the x problem, where you're starting with 20,000 people and they're thinking it'll expand by 5% every year, so that's where the growth rate of 1.05 comes from. So the first question is how many after 3 years, so putting in a 3 for the exponent. And then for the 10 years, you would just put in a 10 for the exponent, and of course round off to the nearest person. All right, number 51 is another start times growth to the x problem, but this time we know that we are ending up with a value of $7,400, and we do not know what the SUV, what the starting value was. So if it is losing 1/5 of its value, losing 1/5 is the same as losing 20%. So we have to do 1 minus the 0.2, and that's where the 0.8 comes from. And the exponent is for 5 years. And so if you do that 0.8 to the 5th and divide both sides, you end up with, and I'm rounding to the nearest dollar, that the SUV was worth about $22,583 when it was new. All right, 52 is a half-life problem, so we've already looked up that formula. In this problem, the plutonium-240 has a half-life of 6,537 years, so that goes in where the H was. How long does it take 50 grams to decay to 40 grams? So we put 50 in for the starting value, 40 for the ending value, and of course the growth in a half-life problem is 1/2. Again, before you do the log of both sides to solve for that t, you must divide both sides by the 50. And then after you do that, I'm just calling this 0.8, then you can take the natural log of both sides and pull the exponent out in front. So this would become, I guess you wouldn't have to do natural log. Just do the log of both sides, pulling the exponent out in front, t over 6,537 times the log of 1/2. So if you do those logs, divide them out, multiply both sides, you end up with 2,104, rounded off to the nearest year, to the 2,104 years. All right, in problem 53, when we see the words compounded continuously, we know it's the formula with the E in it. And this church wants to invest $15,000 for 18 months and wants to know how much money they'll have at the end of that 18 months. So when you put in the percentage rate, the 4.6, that's the 0.046. 18 months is 1.5 years. That's where that came from. So this is just straight up calculator work. If you multiply this out, you end up with, they would have $16,071.54. All right, problem 55 may not be perfectly clear how to go about what they're asking. They are giving us the formula for the culture's growth in that A times E to the KH formula. So we're just going to use the formula given. And if 50 of the protozoans grew into 70 in 8 hours, we just plugged in the start at 50, the ending result at 70, and the 8 hours. The K in this formula is a constant that we are not given. So that's before we can write the formula that they want for part A, we need to find this K. So again, divide both sides by 50. This time you are going to have to take the natural log. So the natural log, I'm just going to leave it as a fraction, of 7/5 equals 8k times the natural log of e, which the natural log of e is 1, so it's not needed. I'm just going to write 8k. So if you do that and divide both sides, this is the first piece of information. We need the fact that k is 0.0421. So now that we have that, now we can complete part A and write the formula. The formula then becomes P of H is 50 times E, using this value K that we found, to the 0.0421 times H. And now we can use this formula for part B when they want us to find out how long it will take the culture to reach 100. So that's your ending value. So for part B, we put in the 100 and then use the rest of the formula. And again, divide both sides by 50 and then take the natural log of both sides. So we end up with the natural log of 2 equals 0.0421h times the natural log of e, which is just 1. So dividing both sides, we found that h is approximately 16.5 hours. Part C in 55 is asking you to tell them the hourly percent increase. Now you may not realize it, but you already have that. Just reviewing that this, even though there's an E in it, this formula is still start times growth to the x, where the start is this 50 is the start. The growth is this e to the 0.0421, and the h is the time, that's the exponent. So again, the start for this particular problem is 50. The growth is e to the 0.0421. That's a constant. And then the unknown is the h, is the amount of time. So when they ask you for the percent increase, it's right here. It's in here. That is the growth. So just do that on your calculator. Do e to the 0.0421 exponent. And if you do that, I just rounded off to 3 decimal places. You get 1.043. That's our growth. The growth is 1.043. And so how much percent is this culture growing by? Well, the 1 represents the original amount of the culture, and this, remember when we're given the percent, we put it into the growth. So 0.043 as a percent is just 4.3%. So that is the hourly percent increase of this particular protozoan culture.